Okay, so we're practicing solving identities here. Uh, this is um, not even the day before the test. This is 2 days before the test. So we just wanted to do a few practice. And to get this one, you have to know a little bit about how fractions over fractions work. Okay. Could you replace that with something? Yes. So it was kind of like begging to just be replaced with its reciprocal, right? Which would be tangent. So then that's tangent theta over 1 over secant theta times sine theta. Did I just make one change? Yep. So that's good. Don't try to do two things at once. All right, next, I'm going to bring it down and say tangent theta is fine over what does secant theta change to? 1 over secant would be cosine times sine. And bring it down. And the next one, do you remember that strategy called change everything into sines and cosines? If you hadn't processed that yet, it's a good one. Okay. Right now I have a cosine and a sine, and the only thing that isn't a cosine or a sine is the tangent. So I should try taking tangent and changing it into sines and cosines. Now, I can go, and there is more than one way to do this, but I can change tangent into sine over cosine, and it would have fixed my problem. But there's a faster way. Who has a faster way? From here. Did you all do what I'm about to say? Change tangent into sine over cosine? Is that what you did? Okay. All right. That's fine. We can keep going that way. All right. So tangent changes into sine over cosine over cosine. And that's all times by sine. Whew. Now, if I'm trying to prove something, it's often good to go look at what I'm trying to prove it's equal to. Because I could morph this into a lot of things from here. But if I know that I want it to be tangent, what is tangent again? Sine over cosine. So really I'd like this thing to simplify down to sine over cosine. So then I don't really want to get rid of this sine, right? I want it to have a sine in it. And then I want to have a cosine on the bottom. So I'm not going to try to cancel that sine right now. So I'm going to instead figure out how to take this fraction and, oh, this is a fraction over a fraction. Notice I just put in and divided by 1. You can do that. That doesn't count as a whole extra step or anything. Okay, now I'm going to flip and multiply. This becomes sine theta over cosine. That did not flip. The bottom one flips. 1 over cosine. And that times sine is what I have now. Now I can go through and see if there's anything that cancels. Absolutely nothing cancels. But that's okay. Because what I have left is, if I put this over 1, is sine. There's 2 sines on the top, so that's sine squared. There's 2 cosines on the bottom, that's cosine squared. And then I know I keep looking back at what I want to be. I want to prove it's tangent, so hey, I pretty much have it. This is tangent squared. And that's equal to tangent squared. How do I check your proofs? I look at the end and see, did they say this? And you'd wish I would just stop right there, because that's never wrong, because kids know that that's how you have to end. But sometimes they had to make creative leaps to get in this problem and say, well, isn't this equal to this? And they skip a bunch of steps, and no, I can't give you that. You got to show me step by step how it changed. Yes? Good question. We will never ask you to prove something that isn't true, because otherwise you just keep banging your head against the wall thinking, I must not be doing it right. No, we'll only ask you things that are true. Prove this true thing. Okay. All right. He's backing up because he has to go early. All right. So your next kind of problem is from the file from yesterday. Not the one we just used. Sorry, it's actually a couple days ago, and I showed you that while we were on a little break a second ago. This page. Raise your hand if you have found this page. Excellent. If you haven't yet, find it quickly. Now, I skipped over a bunch of easy ones because we just did some easy ones in class. Now you need to really work at some hard ones. This is a little bit like lifting weights. Lifting the easy ones helps a little bit, but you won't really build muscle unless you work on some of the hard ones. All right? Now, these can be done by manipulating this side and turning it into that side, or the other way around. Now, if I give you the first step, it makes a huge difference. So I'm not going to do that. That will give you too much help. That's not the test. They're not going to give you the first step. So you have to figure out the first step. All right. Last thought. There is two different ways you can do this kind. You can do it with conjugates, where you would multiply by what right here? What would the conjugate of that be? Well, it depends on which one you mean. If that one's conjugate would be what? 1 minus tangent. Now, I'm not saying you should do that, but you could. Not squared, sorry. You could do 1 minus tangent on the top and the bottom. Option B on this kind is this tangent can be replaced with either 1 over cotangent, right? That's what tangent is, right? 1 over cotangent. Or, probably smarter, what? Sine over cosine. So, if you want to replace tangent with sine over cosine, we know that's true, right? That's the only two ways that you can go on this kind of a question. So either use conjugates or changing the tangent into sine over cosine. And then if you do that, I just want to lead you a little bit. You'd have to get a common denominator, and wouldn't 1 be able to be made into 1 over 1 and then have a common denominator with that? If you can't do common denominators, you can't get an A on this next test. You have to be able to handle common denominators. All right, so there. With that intro, you can spend the next about 10 minutes trying to solve these two questions with your partner. Okay? If you get a breakthrough, talk to them. Or maybe you want to say, you try this way, I'll try that way. We'll see which way works better, kind of thing. It's up to you. But work with your partner on these for about 10 more minutes. All right. So I think it's time to get some feedback here. Did any of the groups feel like they got both of them completely? All right. Then let's talk about the first one at least. Can you at least see what happened first here? Tangent got changed into sine over cosine. Okay. Now, is this the only way to do it? No, you might have an awesome other way to do this. As long as you show every step, we're good. But you'll know if it worked. If it worked, of course, the answer will be the same as it says in the original. All right, so I'm going to keep going one step at a time. How did they make that change? The teacher replaced a 1 with a what? Wouldn't it be easy to follow if the teacher did that? Okay. And then, underneath that, it's a little messy, but that also got changed to cosine over cosine. And why'd they do that? So they have a common denominator. The plus sign's up here, which is a little weird, but okay. Then, going a little further. Sorry, jumps around, it's a long proof. The top two get put together, and the denominator is cosine. Same with this one. They both have a denominator. Oh, I hate when it does that. They both have a denominator of cosine. Now, this teacher did something that I would allow you to do also. Do you get that the teacher here flipped and multiplied this, and when they did, those cosines would cancel? You see how much time that saves to just go cancel, cancel? It does cancel. Okay, and then, whoa, we're left with cosine minus sine over cosine plus sine, which is exactly what we were supposed to prove. It's now equal to that side. Whoa, undo that. Okay. So, did you just hear me? I would allow you to cancel like that the bottom parts of the fractions, if they're the same, then they would cancel. It's sort of like saying this. 2/3 over 4/3. Do you get if I flip and multiply this thing? It's going to be times by 3/4, and the 3's will cancel. So I'm okay with, because these are really complicated trig equations, noting that, yeah, they will cancel. So you would be able to cancel like that and that. Okay? Keeps you from a whole lot of rewriting. All right. So how many of you were successful on the first one? I'd say that's 90% of the class. Good. Is this the way you have to do it? Nope. But this is a way that would have worked. How many of you went the route of cosecant changes into 1 over sine, and cotangent turns into sine over cosine? Or sorry, cosine over sine. What is that technique? I've said it before. Change everything into sine and cosine. Does that always work every time? Nope. But it works sometimes. All right. So now that everything's in terms of sine and cosine, if you get common denominators, it gets ugly to get all those common denominators. And it jumps around. I've got to be patient. Don't have much choice. So on this one, looks like multiplied by 1 plus cosine. Why would you take 1 minus cosine and multiply by 1 plus cosine? Because that's called conjugates. If you do conjugates, this becomes 1 minus cosine squared. Why is it good to get 1 minus cosine squared? Because that's the same as sine squared. What did they multiply by here? They had 1 plus cosine, so they multiplied by 1 minus cosine. I know it's really messy, and I apologize, but it's better than no work. Okay, so they multiplied by and did conjugates. It wouldn't have been as easy to use common denominators, but you could have. So this one involved common denominators and conjugates to get a final answer. That looks, come on. I'm just going to pull it this way. Whoa. I got to get this out of here. Like that. If you go from the bottom, which is what I get to do as the teacher, to grade them, each step isn't that bad. I can go, oh, that was cosine over sine is cotangent. Okay, that makes sense. And then, oh, they just canceled off a sine. Okay, that makes sense. And if I just keep moving up, it's had a sine squared and an extra sine in it. That makes sense. Oh, that's just sine squared. That makes sense. All right. Next, you need to know what your homework is for tonight. Stop. Don't move. Okay, so here's where your homework comes from. We had just done day 1, which is right here. Okay. And I know some of you may not have been able to do this yet. Maybe you'll be better at it this time. I am reassigning to do all the problems now. I had to skip a little bit before, but on day 1, including this and this. And then throw in this one, which is one that we didn't do before for sure. So you're finishing up the day 1. And then we're not doing this one. You may skip the one with the little kitties on it. And you can skip that one too. In fact, I'm going to just say that's it for day 1. Now on day 2, this is important. Do this first page of day 2 only. Okay, now the directions are, you're going to make yourself a little triangle for where this is. Okay, and figure out sine of 2 theta. How are we supposed to know what that is? It's on the sheet. Sine of 2 theta is 2 sine cosine. And you do that for this triangle that you have drawn. Okay? So, all you're really doing is finishing up some problems on yesterday, and the new day is day 2. You are just doing the first page of day 2. All right, that's all I got for you for today.